It is Containers 101, so the assumption there is we're starting from pretty close to zero. So hopefully that makes sense. And what I'd want to ask first is if Joseph, I already know what container experience you have, so you're already a thumbs up. Yes, you've used containers and you know how to spell containers. But Aaron and Bruce, have you used containers before? Do you know what containers are? Do you know how to spell containers? Clueless. You have some interest because you showed up. So thank you for that. I'll assume no news is good news. We're going to stay on Containers 101 level type discussions. My intent, my desire is there's so much to explore in the area of containers these days. Once we've level set and done a few things tonight, to have follow-on sessions, not necessarily done by me, but by others in the community. And again, there's a lot of areas to explore, and we'll talk about that a little bit as we go along here. But again, just another reminder: feel free to ask questions, throw out ideas, give me some of your experience, failures and successes as we go along here. Please do feel free. So again, I think I covered most of this. We're going to do a quick level set, review some options for container hosting, and then do a few quick demos. I'm guessing about an hour or so. I think that based on feedback, an hour is better than 2 hours, probably both for the presenter and for the audience. And toward that end, we do have a survey that we sent out. If you have feedback for us, do hit the survey on the Meetup and give us some feedback. We'd love to get it, and hope to grow the engagement as we proceed here. So containers. Why would I want to use containers? Well, the classic alternative to deploying containers is deploying applications and software onto VMs. Containers are much quicker to spin up than a VM. Of course, a container assumes you have a VM. We'll get into that in a little bit. But they're also much easier to manage. It's a lot easier for me to compose a container than it is for me to compose a deployment to a virtual machine. Now, yes, there are other technologies, and a lot of technologies have been developed over the years to increase the reliability of what's been deployed to a virtual machines and ensure that state is consistent in virtual machines. Things like desired state configuration with PowerShell, Chef, Puppet, and dozen probably more other sort of technologies. But really what it comes down to is that containers are a lot easier to compose, they're a lot easier to manage, they're much easier to change and redeploy, also very scalable. And again, this assumes that there's a platform that underneath the containers that will scale. But once I've established that platform, it's easy to start with one container and then decide, hey, tomorrow I need 2, and the next day I need 5 and 10 and 20, and then maybe the day after that I'm back to needing 1 again. That's some of the benefit of investing in the infrastructure if you have those sorts of usage patterns. Toward that end, a couple of patterns that we've seen in our customer base are things like we do work for HoopFest, Spokane HoopFest.
Hello?
3-on-3. Hello?
Yes?
Yeah.
Hey, this is Jim Burns.
Yeah.
You're off mute, whoever you are. We're very interested in your conversation, but maybe we'll pick it up later. Hello? So the HoopFest, we actually use Azure services for HoopFest. Before that, we were using VMs. Actually, it's gone through a couple of different life cycles.
There.
Hello? Is there somebody asking a question? I'm going to assume no and keep moving. So the paradigm there, the model there is this very large 3-on-3 tournament, 20-something thousand players that are, or 20,000 teams. It's a lot. It's huge. There's a couple of key events that happen throughout the year. Most of the time, nothing's happening. The whole event is one weekend, and there's a couple of key events before that. It's when registration opens, and thousands, literally many thousands of people are pounding on the website to sign up. And then at some point, brackets are released. Thousands of people again are pounding on the website to see brackets. And then again, for the event weekend, we have online status and game updates and those sorts of things where the weekend gets pretty crazy too. The event occurs over Saturday and Sunday. Saturday morning, people are going nuts. By Saturday afternoon, people have, lots of teams have lost and people aren't involved anymore. So they're no longer looking for bracket updates and status updates and et cetera. So there's these it's very spiky, hugely spiky. The rest of the year, nothing's happening. I mean, I could run it on the website on my phone and not have a problem. Even one of my old phones, I could pull out of my drawer and drawer of broken dreams, as it's sometimes called, and run it on that. But those key events, forget about it. You need to scale quickly. We've gone through a couple of incantations. The prior incantation was VMs running in AWS, and those actually took a while to scale. The scaling was very difficult to set up, very difficult to manage. It's certainly easier than managing on our own, but the VMs were a bit of a pain, also very expensive. We actually switched everything over to Azure App Services, which can run containers, and that has been, order of magnitude cost savings. Meaning, if they were spending $100 before, they were spending $10 now. I mean, it's relative numbers, obviously. But that's the kind of savings. It might have even been more than that, frankly, because even with the VMs, you've got to have at least a couple of VMs spun up all year long, just to handle load balancing and be ready to scale and all this sort of thing. So even with that, even when there's nothing going on, we're still spending money. All right, so long story, but that's one scenario. Another scenario is machine learning. So you drive a whole bunch of data, add a bunch of containers, let them scale up, do a bunch of number crunching. Your number crunching is done. You come up with an answer or come up with an algorithm. Things scale down. So anyway, there's a couple of case studies, reasons why we want this, why we invest in the infrastructure, and containers actually make it easier. It's easier than it's ever been to build solutions quickly, easily build solutions for these scenarios. All right, I've been talking a lot. I'm going to keep going. Don't be afraid to ask questions. Slow me down, speed me up, whatever. Usually I can't go much faster because I'm usually going real fast. A lot of times you have to slow me down. So consistency is a key attribute. We build a container. It's the same container. It's an immutable bit set of bits, container of bits that I can ship around, spin up, spin down. It doesn't change. By default, containers are stateless, so which is a good thing for scalability. There certainly is state that we have to manage, but by default, a container itself is stateless. It doesn't maintain state on its own. Another instance isn't going to conflict. Now, again, if we're calculating values, calculating results, taking registrations on a website or something, that state has to be stored somewhere. It's just typically not stored in the container. They are secure and cloud independent by default. You have to beware of cloud independence. We'll talk about that in a little bit here. So containers, what does it look like? If you're running on a Linux box, physical or virtual, so an actual Linux box or a virtual machine, you're going to have container support. It's been built into containers containers have been built into and Docker, which is the container provider of note. It's really synonymous. Has been synonymous for quite a number of years. There were other competing technologies, but I think everybody else has given up. There's this Open Container Initiative, or OCI, but still we all talk about Docker. You have Docker by default. So if we think about what a container is running on, from the bottom up, we have the host server, we have an operating system, which includes container support. We have an application, and in this case, this VM or this physical machine is running 3 containers, an A, a B, and a C. The binaries, whatever libraries that container is running, are isolated within that container, and then they are not shared from container A, container B to container C. Container A, container B, container C may be using the same set of binaries. Say they're all core apps, or say they're Python and there's a Python distro within those containers that's of the same version level. That is not going to be shared. It's going to be inside the container. The beauty of that is if container C suddenly wants to update from Python 3.8 to 3.9, container A and container B could care less. They're going to be able to continue to run. So again, there is a security and isolation container to container to container. There's no way for a container A to infect container B. Now, if container, if you're not careful, you're not watching out, there are ways that you can set yourself up for issues, because I can set up container B to write to the OS, but I specific and read from the OS, but I specifically have to allow that and tell container B to do that. And obviously, if I set up container A to do the same thing, there's a possibility for pollution, but there's also, best practice is obviously not to do that. So we're going to keep going. I can also run containers on Windows. So with Windows, I'm installing Docker for Windows. These days, when you install Docker for Windows, you'll want to configure it for Windows subsystem on Linux or WSL and version 2, because that will be what's running your Linux distributions, and it's much faster than WSL1 and much faster than other incantations, which involved making sure that you had VMware, Hyper-V and enabled and et cetera. It was doable in the old days, but not pleasant these days. It's a pretty seamless and nice, quick, rapid, fast experience. Other than that, the same scenario applies. It's just that, hey, if you're running a Windows system, you need to run Docker for Windows on your system. Basic architecture, basic overview of what containers look like. So far, so good. I'm going to keep rolling. So I got a diagram here, 3 containers running on top of Linux, which natively supports containers, and infrastructure, again, which is either a VM or a physical machine. And then we have Windows subsystem for Linux. It's for all practical purposes, identical, except I need this Docker for Windows install to get things into my Windows binary. All the Docker commands are identical. Container structure is identical. I'm still provisioning to Linux to Linux, for example. There is such a thing as Windows containers that have been around for a while. Not very popular. Again, the de facto standard for when we're talking about containers is Linux and running Linux OSs. And if I need a specific OS, there are ways to load up different OS versions. The nice thing about Windows is that there's a couple of different distros that it can support pretty easily. So no real downside if you're running Windows on your desktop. If you're not, then it doesn't matter. Okay. So what is Docker? Uh, Docker has a pretty significant command line interpreter, command line interface. We'll take a look at some of these commands. It's very extensive. We could spend hours and hours and hours going through all the commands in the Docker command line. We'll focus on a few that are relevant. The Docker command line itself is just a wrapper for an API, which you can call on your own, no problem. REST API, everybody's doing REST API. And then it talks to a Docker daemon, which does all the management. Service, server process that runs, which does all the management. That's going to include things like building container images, managing the container, and various tooling that are going to be needed for Docker, or for your Docker, for your container, et cetera, et cetera. The way we think of Docker typically is building it up in layers. We have, at the bottom, the base OS. What OS do you want to run your container on? And it has to be supported by the environment. You can't just pick random OSs. It has to be something that is going to be supported. And again, generally, if you're picking normal OSs or standard OSs, you don't generally have to think about this. But there are edge cases, like there's special versions of Linux that are really tiny. You just have to make sure that wherever you're deploying to supports that OS image. Otherwise, you're not going to get the benefit of the tiny OS image. Whatever frameworks and tools, right? You have an application, it's going to require something to run on. Python would be a classic example, .NET Core, or something like that. Anything else that your tool needs, and then finally your application. What Docker uses to define what a container looks like is a Docker file. That is a file called Dockerfile, which has the definition of the container in that file. So in this example here, we're doing a node, which is that framework that we're building on top of. We're telling the container we want to expose port 3000 from this container. Our working dir is app/app. We're going to copy a package onto that container. We're going to do an npm install, which is going to pull down any references or node modules that the app requires, as defined by package.json. And then I'm going to copy dot to dot, so source to destination. My source is where I'm doing my development, my project directory, et cetera. And the second dot is my target. Where's it going in the container? I said that my work dir was /app, so that's my default location where everything's going to go. So when I say copy dot to dot, it's taking whatever's in my current directory on my drive and copying it into where I'm executing the Docker file, and copying it into the /app in my container. And then I'm telling Docker, hey, when you spin this container up, execute the npm start command. Okay, does that make sense? Thumbs up, looking good. You only see a small face of me talking and the bigger screen with the Docker file on it. Okay, just gonna keep rolling. So there's another file and another technique called the Docker Compose, which basically will take multiple containers and compose them together into a solution. Now, it's not often that let's say simple applications, sure, they might be one container. More complex applications often are going to be multiple containers that make up your solution. Here, common example is something like a Redis cache. Another common example is a Postgres database or a SQL Server backend, something like that. So you can compose these things together and in one Docker Compose, and build all of your containers at once and allow them to be a deployable unit, or help them to be a deployable unit. A compose can either reference other images or build other Docker files, which will build images for you. I think one thing I didn't mention is that there's this rich ecosystem in Docker, and thousands upon thousands of images that people have built up. Again, we're going to demo that in a little bit as well. So you're not always building an image from scratch. You're again building it from something from some starter. Here, this is taking a standard node image that somebody else has created. They've published this to Docker Hub, which is a publicly available image registry. And we're saying, hey, from this standard node image that somebody has created, we're going to build up our application. I could start higher or lower, depending on your point of view, I guess. I could start lower in the stack and say, hey, I want to build this from a Linux, and then build up my own version of Node on top of it, and et cetera, and do my own installs and so on and so forth. I can do that as well. Standard practice is you're going to trust a base image to do your stuff. Not always the case, but often the case. So Docker Compose, what does that look like? It's got a version number. What version number of the Docker Compose structure do I have? And then what I then define are the services that make up my solution. I can specify an image that comes from a registry, or I can say, hey, I'm going to tell you how to build the image, and basically point the Docker Compose at a Docker file that will create the image for me. I can set up networks so that all these images are talking on the same network, and I can set up volumes. Volumes are a way to map to give you storage within the Docker environment. So a Docker volume basically is storage within the Docker infrastructure, which is really on the VM. It's only available to the Docker infrastructure. I mean, there's ways to get at it from outside of Docker, but you're basically executing Docker commands. Okay, I'm going to keep rolling. I think I'm going to keep rolling. Thank you. Yeah, rolled a little too far because I wasn't patient enough. One thing that's interesting, we won't spend a lot of time on it tonight. A way that you can use containers is in Visual Studio Code, which is a de facto tool for building containers. We'll demo that a little bit tonight. And again, we talk about tooling. I forget to talk about that sort of tooling or editor because I'm just so embedded in using VS Code. VS Code is not mandatory. There are other text editors that have built-in or extensions for containers. I'll just be showing VS Code. Recently introduced feature with VS Code is the ability to do dev containers. What's really nice about this is I can spin up a solution that somebody else containerized very quickly and start editing it and updating it without doing any install on my local machine. All I do is spin up the container and I'm rocking and rolling, and I'm able to do code editing. And there's some nice features here where I can edit in my local OS, like in Windows, and then actually edit and debug in a Linux container host. And I know Joseph, for example, who's on the call here, you've done something similar to this with VS Code, where you're editing using VS Code on a Windows desktop and SSHing across to containers that are in an actual Linux VM, not even on the same machine. It's the same technology, but think of these two boxes rather than being on one machine, they're actually on two different machines. And there's a couple of different scenarios that's supported.
All from within a virtual desktop environment.
Oh yeah, right. Meta, virtual upon virtual upon virtual. And we got the Zen workspace to to a VDI, which is actually a VM, blah, 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 blah. I said too much already. It works. Sometimes it even works well. But actually, the VS Code to remote container experience is pretty slick. Moving right along, cloud deployment options. There are many cloud deployment options. So I've built a container. I can run it locally, party on that. I can, create a VM somewhere and deploy containers to this VM, to the VM. And again, that's a center for a project that I know Joseph is working on now. That's what he's doing. He's got a VM where he's spinning up instances of containers running on that VM, and people are hitting that VM to get containers on that VM to get what they want out of it. There are also cloud deployment options. What's really nice about this is I can have a container, I can run it on my local machine, and then I can say, hey, I want to deploy this container to a cloud. Could be Azure, could be AWS, could be GCP, could be this, that, or the other thing. There's, again, dozens of options. Search for cloud container deployment options or something like that. Google that and have fun reading all the different options. Within the clouds, there's things happening all the time, but there's a set of core service types that people are generally deploying to, and for different reasons. Kubernetes is a container orchestration platform that Google created to help them manage their server infrastructure for search and ads and all their applications. So they built this thing so that they could, spin up containers, manage containers, scale them up, scale them down. If a container died, restart it. If they're, again, getting heavy loads, add more machines, et cetera, et cetera. They didn't want to do this manually. They needed to do it automatically. So they invented this thing called Kubernetes. They open sourced it, and it's been picked up by the industry. It's the de facto standard these days. There were other orchestration. There are other orchestrators out there. Docker had one called Swarm, and it didn't really take off. I don't know. I'm sure there's people out there using it, but we generally don't talk about it. So, and we say orchestration. I mean, think about an orchestra. There's 35, 40 players. Whatever. I don't know what the smallest orchestra size is for it to be called an orchestra, but think larger enterprise scale, bigger needs, bigger solutions. Heavy duty, thousands of requests a second sort of scale. Applications and things, like Google search that have to stay up and run for a long period of time, or machine learning, AI type stuff that's got to scale very high and maybe ramp down very low depending on need. It's a good way to do it. It's complex, but with that complexity comes a lot of that scale level benefits. Those scale level benefits. Azure also has a thing called Service Fabric, and you can write native components or services within Service Fabric, and again, these are microservice type solutions. There's also Azure Container Instances. You could do some scaling with Azure Container Instances, but typically this is thought of as a onesie, twosie, a 3Z sort of implementation. Very easy to implement, a little bit more expensive, on a container by container basis, but real easy to deploy. And you get some built-in features with Azure Container Service, like automatically do load balancing. With Kubernetes, you got to configure load balancing or bring your own load balancer, et cetera. Again, we're not going to get into Kubernetes. That's a great topic for multiple future discussions, talking about some of the things you can do with Kubernetes. Azure also has an app service, which we typically think of as a platform as a service offering. You can deploy code directly, your .NET, Java, I think it supports Python, supports Node, et cetera. You can take your solutions and deploy them directly. You can also deploy a container onto app service, little known feature perhaps. There's also function containers. So we talk about functions, which is, quote unquote serverless. you can actually create containers that have functions if you so desire. You have to watch out though that because these function containers are they're no longer portable, let's say, they have stuff built into them that are going to be specific to functions. Azure also has a thing called batch, which is a different form of different form of scale. On the AWS side, there's a similar set of features. They have a EKS, Elastic Kubernetes Service, as opposed to AKS. They have Elastic Container Service, similar to Azure Container Services. One might think of Elastic Container Service maybe as a notch up. It's a little bit more complicated. With Elastic Container Service, you either bring your own VMs, which are EC2 instances, what are called EC2 instances in AWS, or you can use something called Fargate, which are VMs that AWS manages for you and spins up as you need, et cetera. Again, more expensive, but you don't have to manage them. EC2, you got to create them, create your instances, and then provide them to ECS to manage. Somewhat recent, I don't know how long it's been out, a year or something like that, maybe longer, depending on what what beta, production, et cetera, is a thing called Lightsail, which again is sort of maybe somewhere between app service and Azure Container Service on the Azure side. Again, very easy to deploy. I've got quick demos of both ECS and Lightsail. But Lightsail, you have less to do, slightly more costly, but you're not managing anything. It's pretty quick to spin up a container. You wouldn't expect to do, machine learning on this. It's limited capacity type things. App service is not a thing. So scratch that. Not a thing on AWS. It's copy paste run amok. Lambda, AWS has this, serverless Lambdas. Lambdas can run containers, but again, if you're going to run a Lambda container, you're building a container that's specific to Lambda functions. There's also App Runner. It's not called App Runner. Sorry, there's another service that they've come up with, which is somehow even easier than all these other options. I don't know. Some of it's marketing. I haven't done a lot of investigation in that solution. It's not something we're going to typically do, except for maybe a demo, something like that with our client base. But you still want to be aware of these things because it may become, you never know when you're going to run into a situation where it can be handy and something you do want to use. Typically as you sort of work up the scale with regards to ease of use, you've got less flexibility, generally less scalability, and more cost. Again, if you're running hundreds of containers, how much you pay per container is going to matter. If you're running one, may not really matter how much you're paying on a per container basis. Okay, demos. I'm rocking through this, going quick.
Phil,
Joe, so far the only one on the phone now.
Phil, what about GCP?
Got somebody new. Look, cool.
What about the Google Cloud Platform?
What about the Google Cloud Platform? How long do you want this thing to go on, man?
I'm dying to know about it.
You can cover the Google Cloud Platform in a future DevOps meetup, Joseph.
Fair enough.
And again, there's dozens of other ways to host containers. Literally, probably more than dozens. I didn't count them. So, okay.
Called OpenShift.
Oh, so OpenShift is Kubernetes.
Right.
And what OpenShift has an additional management layer on top of Kubernetes to make it even easier and better. Air quotes. So, if you're really used to, let's say raw Kubernetes, you're like OpenShift is, too much stuff. If you're used to OpenShift and some of the things that it provides, you're going to like OpenShift. And let's boot this conversation because I'm going to violate my time limit if I'm not careful. But definitely an interesting thing to explore in a future discussion. In Kubernetes, you can spin up your own Kubernetes service. You don't have to use AKS or EKS. You can spin up VMs and install all of Kubernetes. What AKS and EKS does is basically host the management node. So Kubernetes as a management node, and then actual worker that you deploy, worker nodes that you deploy your containers into. With AKS or EKS, Azure and or AWS does it for you, and GCP has a similar offering. So it's a bit of a hybrid between IaaS and PaaS. You know, it's PaaS-ish or something. Okay, demos. Enough PowerPoint. Enough me rattling off stuff. We will stop presenting, and then I'm going to do screen 2. And we will pull up actually we'll pull up this, but you should see a VS Code screen. And a PowerShell window. I am on Windows, as evidenced by Windows PowerShell, and I have Docker running here. And if I just do, you can see a little bit of evidence of prior commands that are running. If I do a Docker PS here, there isn't currently anything running. And Docker is the Docker CLI, so I can do something like Docker image list and see all the images that too many. 3 years ago. What the heck have I been doing for the last 3 years? I don't know, but it's in there. Looks like I need to do a lot of cleanup. Various stuff that's in here. Another interesting thing about Docker Desktop is it will run Kubernetes for you. So if you're playing Kubernetes, doing stuff with Kubernetes, it's a really nice way to do experimentation and development locally without having to deploy or provision a Kubernetes cluster in the cloud. You wouldn't use that for production, only for development. But FYI. So let's do a little bit of container stuff. I have a little cheat sheet here for my demo, which I'll go and show you so you can follow along. We did our intro, we did our agenda, we're on to demos. So again, Docker, I'm running Docker for Windows. Docker is the CLI. You can, they're included a link here, you know, go explore, just look for Docker CLI and GitHub again, you're going to find a zillion commands. One thing to note, if for some reason Docker doesn't start or the Docker CLI doesn't start, you have it configured not to start, there's some issue, whatever, it's pretty easy to just fire it up. Another thing to watch out for is, depending on what you're building, it's not uncommon, in my world anyway, to get this error. No matching manifest for Windows, and the manifest list entry is kind of a weird error. It's like, what? You need to turn on, in that scenario, you just turn on experimental. So you literally just have to run this command, turn on experimental, and you get rid of that error message. Might save you 5 minutes of Googling if you run into that message. Okay. I'm going to keep going. Nobody's stopping me. So first demo is just running a pre-built container, pretty simple. I'm going to run this Docker command. If I can select it, come on, you can do it. Mouse is not happy with me, not responding. Let's do a clear screen just so we can see what's going on here. And I'm going to do a Docker run, and it's firing up an image. So basically run image RM, just is saying remove the container after I'm done with it. I don't need it. I don't need it laying around. P, which is going to map ports. So this container that I'm pulling up is running on port 80. I'm going to map port 80 on the container to 8,000, port 8,000 in my host system. I give it a name so that I can do things like kill it later. And then I reference an image. So this is a Docker image that's previously been built. If when I hit Docker run, if it doesn't find the image locally, it's going to go reach out to my configured repository by default Docker Hub, and it's going to pull it down. This particular image is from Microsoft, built by Microsoft, .NET samples, and includes a simple ASP.NET app already built into it. So literally all I've done is run the Docker run command. It ran fairly quickly because I've run this command before, dirty little secret. And when I ran it before, it downloaded the image from Docker Hub. If it hadn't downloaded it, I mean, this is multiple megabytes, you'd be seeing, progress bars on my screen as it downloaded the image, prepping to run it. I then have a handy little alias for firing up a browser, which I'll switch to another window here and just again go like so. Oh, come on. Never mind. I lied. I'll do it the old-fashioned way. I don't know why that alias isn't running, but somehow I didn't hit the command in that environment. Oh, come on, let's do something. Pull up Firefox here, just for grins. Old Firefox. Come on, you can do it. And if I do http:// localhost host : 8080. Yeah, no, not HTTPS. I can't see. Look at that. Wow. No certs. Another topic for later. Not doing it tonight. And it's at 8080. No, see, that's why I did the alias, so I didn't have to have stupid typing errors. 8,000. Whew, that wasn't too painful. It really is just the one command. So this is the image that Microsoft publishes to Docker Hub. You see that it's .NET 5.0. I didn't go through any install steps for 5.0, this particular version on my machine. I just ran this container. I probably do have .NET Core, but it's irrelevant because it's not being used or .NET 5, excuse me. It's not relevant. It's not what's running on this machine. You can see that, saying that I'm containerized, how many cores I have. Given how pokey this machine is, you'd think I'd have more cores, or wouldn't have that many cores. How much memory the container is using, and then the max available in bytes. So again, standard container, didn't do anything, load, run, bang, zoom, really cool. Now, obviously, this is just a demo in and of itself, not all that interesting, except for the fact that I ran one command and I've got a web app running on my local machine. Of course, I previously installed Docker for Windows, but once you do that little bit of infrastructure, you get the rest of the stuff pretty easily. The other thing that I've done is deployed that same image to Lightsail on AWS. So let's see if I can navigate there without too much trouble. That's ECS, which we'll be talking about in a little bit. So with Lightsail, again, Amazon service, it's pretty easy to get started. I have an existing deployment, which is this ASP.NET Core sample, which all I did was say, hey, give me, let's say I want to create a deployment. Come on, man. Oof. So I don't want to do this. There's canned deployments that you can. Oh, wait a minute. No, deployments. What the heck? It's just a couple of dialogues, but for some reason, because we're doing a demo, when I click the button, it doesn't deploy. So what I can do is look at the existing deployment that I did. I just called it ASP.NET Core -sample for my container name. I specified the same image that I used from Docker for Windows. Said, hey, open up this port for me, and I can give it a public endpoint, which is just going to be this ASP.NET Core sample. Cancel that, so I could modify it, for example. So again, if I say modify, and off we go. It's pretty much that simple. Under the covers, for me, Lightsail has created a load balancer, so it can connect public endpoints to the container. I don't have to do any of that stuff. I just point, click, bang, zoom. I'm there. I've got a container. I do have capabilities to do custom domains. I get some metrics out of this, and I can scale the capacity. I picked the smallest possible capacity, but you can scale this up to multiple different sizes, more expensive, but it also gives you more scale built into the platform. So then if I hit that handy dandy little URL, I see, different URL, same container, identical, absolutely same container, .NET 5, Linux. Metrics a little bit different. It is containerized, but 2 cores, and memory usage is going to be, I don't know what the differences are, it'd be interesting to see, and bytes available, et cetera. So you see the two different scenarios there. With Lightsail, another limitation that I have is I can pull from a public registry. So if I'm okay publishing my containers to a public registry, that's all good. Or I can deploy from my local machine. So there's a AWS command line, which would allow me to build local and push to the cloud. There are some ways to do this with pipelines and actions. So far, there isn't a default push that I found, though I haven't looked that hard either. Exercise for tomorrow or Monday or something like that. But anyway, making sense? So far, so good. You're asleep, or I'm making a ton of sense, or something. I don't know.
No, you're doing good, man.
Cheers. Keep rocking. Keep rocking. Okay, so back to what's next for demo. So run a pre-built container. We talked about some of the options, and again, there's many more options in this. Run Lightsail. All right, so let's now talk about some Python app code. Definitely rookie territory when compared to Joseph, but hey, this is 101. So in this demo, we're just going to show some Python app code, very small app. I can build and deploy this locally, test it if I want. I can manually push this up to cloud for deployment into container registry, do some stuff in ECS and retrigger, but that's no fun. I've also created a GitHub action, although when I say I created, we'll get into that in a little bit more detail in a second here. It takes about 8 minutes to deploy, so I want to get to deployment before whatever. Just play along. So again, there's some commands there I could use to push by hand, but I'm not going to do that. So we want to go to VS Code, VS Code, VS Code. Where are you? There you are. So let's take a quick look at this. Here's my fancy dancy Python app. It's actually a Flask based app. All it's doing is returning a message. And we'll just say with you again. I think the words go something like that. We'll say, yeah, that's what we got here. Let's fire up a terminal. And in this directory, I have a Docker file. And this Docker file is saying, hey, grab Python 3. So again, that's my platform, Python version 3. It should give me the latest available 3 image available, 3.8, 3.9. I don't have to specify the dot number. I'm okay taking the latest 3. I'm gonna put hello, add hello world, just a little bit different form than the workdir copy dot. Here I'm just taking one file and adding it to the root directory. I'm doing a pip install Python command to say, hey, install Flask for me, and then Flask RESTful, because what I'm doing here is a RESTful API. I'm exposing port 8080. And then when I fire up my container, I want it to do Python, to run Python, passing the parameter .hello world -py. Again, this isn't a Python training class. It's we're just talking about containers here. So again, what I'm going to do here, I do want to make sure I get the right container name, because it's going to be important in a little bit. I'm going to say Docker build. So instead of run, I say build. So now I'm building an image, and I'm going to tag it with the name Lightsail Hello World. Although I'm not deploying to Lightsail, so don't let that confuse you. Prior version of the demo. I just noticed that now. And where am I building? Building the current, in the current directory. So, or where is my Docker file? It's in the current directory. So I'm going to do a build that, what? That figures. Well, yeah, because CumDum didn't change to the right directory. We're in dev, containers, all one, hello. I'm actually there now, and we'll do a build. So this is going to build up my container based on the definition. And again, there's a few things like the Python 3 image. I've built with it before, so it's local. It's going to use the one that's local and not download it from Docker Hub. If it wasn't there, it would download it. So if I change to be a specific version that I didn't have, that would do it. I'm doing a pip install. Pip install by default is downloading packages over the web, similar to what Node would do, or other similar technologies. I'm going to skip the Docker inspect. I'll just give you details. Come on. Oh, man. And we're going to grab the run here. So here, so again, there's various image commands. So if I did Docker inspect, I wanted to see what was in this container in detail. I can inspect it. Another command, the Docker run, few less parameters, but I am mapping 8080, which I said the container was, to 8001. So container's now built. So we're gonna fire that up. And we're now running on that 8001. So if I go to, let's just go here, doesn't really matter, HTTP, whack, local host, 8001. There's my updated code. Just for the record, this is my prior version, which is running on ECS in Fargate, even though it says EC2. It's just an EC2 instance that was provisioned by Fargate, and it's got the old message, or the prior version of the message there. Okay, we back here, we did the demo, and now if I wanted to push by hand, I could execute a bunch of this stuff, but again, I don't want to do that. So what I'm going to do is go back to VS Code. We'll go ahead and stop this guy, and I'll do git status, say, hey, what changed here, git commit -m. More better message, git push. Okay, so I pushed this to demo repo, and we go to Edgy. Where's Edge? Where are you? Too many windows. just use this one. GitHub.com. See what fun awaits. Little Python Flask. That's the repo. So in this repo, I've got some stuff. We'll take a look at that in a minute. I also have workflows or GitHub action. Again, we'll take a look in a minute. And I can go to releases. I'm saying, hey, I've got a new release of my application. Really cool stuff. Really impressive bit of Python code, and it's been tested. Everybody's happy with it. All my test users, etc. So I'm going to create a new release. I'm going to tag this v0.3. More better. Dig it, and I'm going to say this is a pre-release. I'm not that confident, and we're going to publish this. This
Phil,
is,
Can I ask a question?
Yep.
What does the pre-release actually do on GitHub? I've always seen it, but I've never really used it.
It just flags for users that it is not final. It's something you consider pre-release, and you can do different triggers and tags, and for example, you might have a workflow, or your GitHub actions might say, hey, if it's a pre-release, I'm going left. If it's not a pre-release, I'll go right. Sort of you use it in those sorts of ways. So it's documentation, and then you can use it for fun stuff.
Would a typical flow, would you convert the pre-release to like a normal release, or do you just create a whole new release that's not marked as a pre-release?
I would say sure. You can probably go either way. I like the idea of pushing a new release, which is going to be the release. The expectation is that your process, your DevOps process, is you're confident in it, and it might be a version number that you change, right? Something like that. And again, I manually typed it in. You're going to want to probably set that automatically based on whatever your version numbering scheme is. So, I wouldn't say there's a hard and fast rule. My gut would be I'm going to push a new release out that I'm going to be pulling through, whatever my branching strategy is to get it out the door. And again, the release, this release itself, I did it manually. If I'm using releases, I'm probably going to create that automatically based on whatever the input is. And really, do I need releases? It could be that as soon as I do a PR that hits main, it's going out to production, and I'm going to trigger my flow off of that. Right? Yes.
Yeah, that makes sense. Thanks for explaining.
So 2 minutes, so we still have 6 to go. In the meantime, we'll sort of work ourselves backwards here. So we've seen an action that it's triggered. So let's go take a look at the actual action itself. Sort of working our way backwards. And when I say I created this workflow, that's cheap. There's a template built into GitHub for pushing to ECS, Elastic Container Service, which is where I'm going to. And there's basically a step-by-step, punch up your workflow this way or that way. So this is a great starting point if you're going to ECS. Again, there's going to be, real world scenarios are going to be more complex than this, but the core is going to be similar every time. So even if this isn't what you end up using, it's a great starting point. So these first sets of line here are triggering based on a release that was created. So I'm on my 3rd release. The prior 2, again, it automatically triggered, took 8 minutes to run. I then have jobs, and in this case, I've got deployment jobs, because what I'm going to do with deploy jobs, you've got different actions that are going to be available to you. Like, for example, environments. GitHub supports environments. Here by default it's production, but it could have a test environment, a dev, test, prod, stage, whatever. And again, that's an area where, hey, if it's pre-release, I'm going to go to dev, or probably not dev, but stage or test or whatever, something like that, right? It's a it might be to prod, but I'm only provisioning a certain number of containers, like a red, green, or canary deployment. Hey, if it's pre-release, and this is something like Kubernetes and to some degree ECS are going to enable, where I'm going to spin up this container and make it available to this set of users who agree to see pre-release, but production users aren't going to be touched. Okay, so and then I might roll that release out and backwards take off the flag once I'm happy with it. Again, there's dozens upon hundreds upon thousands of different scenarios that we can come up with, but that's the basic idea. And again, one of the things that containers more easily support. Okay, so I'm doing a deploy. I check out my code from that vast amount of Python code. I check that out from Git. I configure AWS credentials. I previously set up secrets. I'm not going to go through all that because we're already running long on time. But I set secrets up in GitHub that I can pull in. I'll show you those if you want, maybe toward the end. I then have to log in to Amazon ECR. So again, this uses a default AWS action. I didn't write the login myself. There's an action that AWS provides to log me in. I then build the image and then push it to a registry that I previously created. So this pipeline is assuming I've got a Elastic Container Registry, ECR, and Elastic Container Service. Within the Elastic Container Service, that I have a cluster created, a service, and a task. All those things are created ahead of time. Again, potential future discussion is, hey, can we provision those via an action or a workflow or CD? Infrastructure as code? Absolutely. But again, not tonight. I then fill in ID of the definition because that's what's going to get deployed, and then I do a ECS deploy task. So here I'm marking the task definition here with my updated image. Here I'm deploying that updated image, and when I deploy it, it kicks the service to deploy my new container. Again, in this scenario, I have one container running, so for the time that it restarts, people aren't going to be able to see my fancy dancy website. Or in this case, I've got a RESTful API endpoint. When they hit the endpoint, they're going to have failures. So let's go to ECS and just walk through some of the things that I said. So in ECS, you have clusters. So this is going to be a cluster of services that you define. I have task definitions. So if I just go to clusters, I've got a couple of demo clusters up here, Python samples, cluster 2, and then more Python, which is the one we're running in. You see these others don't have anything running in them currently. So there's one service, one running task. I have task definitions, which basically define, and I see I'm up to 5. 5 is actually the most recent version of the definition, which was updated by my pipeline. I created the first one by hand. The other 4 were created by that pipeline. With a template, you could even have the first one provisioned. You don't have to do that one by hand and generally you don't want to, right? You want to set the values and have your automation set them for you. But you can see I'm grabbing this container called Hello Python, and it's coming out of my container registry that I created. It's got the host port 8080, container port 8080. And there's actually a load balancer front end provision that maps that port out to the public. I can have mount points, which again, container thing we didn't talk about tonight. Volumes, which would be Docker specific. I can mount volumes. This would all be Docker specific. My container happens to be pretty simple. It's other configuration, not particular to this container definition, which would, let's say, go talk to S3 buckets or AWS RDS or data services, those sorts of things. That's going to be a fairly common model. I'm not going to store my state in the container, obviously, because they're idempotent and they don't store state themselves. It's either going to be in the volume or I'm going to be connecting to a outside service, databases, Redis cache, yada, 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 Postgres, QL, blah, blah, blah. Onward and upward. Okay, so I've got clusters and tasks. So if I look at my clusters that I have defined here, I've got, hey man, clusters, just having a great time. So if I go to more Python, I can see that I created a service. The service has a task defined for it and a task instance. ECS instances, there are no ECS instances because I'm using Fargate, and Fargate is managing the servers. And you can see here I've got a Fargate VM that was created for me by AWS that's running my container. So I still have that VM, but I haven't had to worry about it other than telling, when I created this stuff, telling ECS how big I wanted my container to be. Let's see, anything else I can tell you here? There are metrics that I'm getting by default when I build this. This is a pretty simplistic scenario, so there isn't really much being shown here. I can also configure this to schedule tasks. So if I want to run it nightly or periodically, whatever, it doesn't have to be a website. This is just one scenario, and then various ways to provision additional capacity. Okay, enough talking. Let's first double check GitHub. Go back to my action and see, yeah, more better. Took 8 minutes and 50 seconds, 7 seconds this time. So theoretically, when I refresh, I get my, it's good to talk to you again. So yeah, I did a lot of talking there, a lot of pointing and clicking, but really all I did was push commit to a repo and create a release. I could set my triggers up so that either the release was created automatically by some outside event, or that I just pushed whenever, or that I just pushed a release whenever things were committed to a branch. A classic scenario might be I've got a dev branch, a staging branch, or dev, test, stage, prod, whatever. That's one way to set it up. So if I pull something into, I accept the pull request in a dev, trigger deployment to a dev environment. Test, same. Stage, same. And then production, I'm pushing out to my production environment, which might be, a dozen containers running to support my massive website doing whatever the heck it's doing. Okay. 7:18, so we're still in the 7-ish. If you're willing, I'll go do 1 or 2 more things and then we'll call it a night. Okay, so .NET with Docker Compose. This is an interesting example. I think we'll leave this. It takes a while to spin up, but a couple of years ago, and I'll include links. You can also go to our website and look for Docker. We had one of our team members, no longer with us, unfortunately, great guy, Thomas Rubel, who wrote a couple of blog posts about .NET with Docker Compose. Again, this is 3 years ago. I cloned his repo. Now, I forked his repo before I cloned it, but I didn't make any changes to it. You can see this, and again, I could go directly to his repo from 3 years ago. It hasn't been a commit in 3 years. I clone it. I can go do Docker Compose up, which is going to use a Docker Compose file. It will spin up 3 different containers: Angular front end, .NET middleware, which is just a .NET core, I think 2.x vintage in that time frame, and a Postgres database on the back end, and run a simple website. All I did was a clone, a Docker Compose, and I'm running a website. Again, it takes a few minutes, but to have fun trying it at home. It literally works that easy. There's a couple errors here and there, but it still, warnings, whatever, but it still works pretty much out of the box. If we take a quick look at the Compose, just to show you what that would look like, I will do a file, open file, and go dev containers, and we'll open .NET Postgres Docker and the Docker Compose. So again, version 3 Docker file uses a volume for local Postgres data. Basically what that says is I'm going to spin up a container with a database. I don't want to store my database data inside the container. I restart the container, all my data is gone. So in this scenario, I'm going to say, hey, Docker, store this data, store the database for me. In this scenario, I've got 3 services, a web front end. It's going to be built web. I would usually think of that as the back end, but whatever. Web back end. Okay, fine. Web back end. So I'm telling Docker, use the /backend directory to build my container, to build my image, excuse me. And then I'm going to map a couple of ports, 5000, 5001. I have to have a DB for this service to be worthwhile, so make sure I spin up a DB, so it depends on, and I want the DB before I spin up my service. And then I've got a couple of back-end volumes here where I'm just going to store my bits, my build bits that I want available. I also have a DB. This is not doing any container build. It's downloading Postgres, an older version. But again, I didn't touch this file, so probably current 3 years ago. And give this database a username and a password, very secure. Obviously, this is local development. And then use this volume that I previously defined. This allows me to give additional characteristics to this volume if I needed them. In this case, I don't. I can just take the default, and then the front end is actually an Angular app. So 3 completely different technologies. This is a .NET Core backend, Angular front end, Postgres database. But all I got to do is Docker Compose up, and I get the application going. The other thing is that I've got the source here. I can make changes, tweak it, and I'm very quickly, no excuses. I don't have to configure my machine. It's done. It's done for me. And with some of the dev containers and remoting into containers, I can set breakpoints and debug and interactive debugging and that sort of thing. It's all supported in these environments these days with the right tools. Okay, so that wasn't really a demo, but again, it would have taken a few minutes, and heck with it. If you want to see it, happy to do it. You can also do it on your own. And again, just to further the point, we actually have a project in progress where we're taking a VM-based Django Python app and migrating it to containers, because I think ultimately that's the better thing to do, and it's not going to be very hard. Would they currently deploy this either to Python Anywhere or to VMs running in Google Cloud Platform or GCP? But if I just do a quick Docker, well, actually, probably I can just do this. I don't have to do a build. What I'm doing here is I'm doing a Docker run. This is the name of the container, saying, hey, run this command when I spin up the container. Just run a shell for me when I spin up the container. And if I go to, say, this guy, so now I'm in the container, and I can do something like a uname -a and see that, hey, this this is my Linux container. Can I do a Python dash version? And I could be playing around in here doing stuff. Listing a directory. This is the what makes up the directory for that application. If we take a look at the Docker Compose real quick. In this case, at the moment, it's an app and a database, so a little bit simpler, but I've got a database, Postgres database, and then this Django app, which is again just a Python framework for building web apps. And we see that it builds Dockerfile. If I take a look at the Dockerfile, I'm building from 3.8, the Slim Buster version. Hopefully it's smaller than the gigabytes of normal Python. I'm exposing port 8000, providing a couple of environment variables. And if I go back to my shell, just do env, we can see that I got a couple, got those environment variables set, Python buffered, Python bytecode, and a couple of others that are provided by the commands that I ran. So set a couple of environment variables, copy some requirements in, run a pip to download any packages that I need, set a workdir /app, copy everything from my current working directory into app. There's a Docker ignore that I can specify to prevent files that don't need to be in the container that I just use for development, et cetera, from going into the container. I also know that this image, when it runs, it needs a logs directory. It doesn't create it automatically, so I create that for it. And there's a static telling Python Django where static stuff goes. Add a user, and then there's a few more commands that will run once we get things figured out. But the idea here is every time I build this container, I can run these setup commands. I don't have to worry about it. It's all built into this one nice little package. So ripped through a bunch of stuff. Didn't bother slowing down. You didn't tell me to, so I'm going to blame you if I went too fast. Hopefully I went fast enough, and hopefully this was useful and helpful. And again, I think there's a number of sessions that we can do beyond this, exploring areas, whether it's Kubernetes, logging. We didn't really talk about logging or monitoring. By default, I'm going to get logs that can be processed out of these containers, which is a key part of this whole story. So, questions, concerns, suggestions for future meetups, follow-ons to this session. I'll take that as a no. Thank you for coming. The YouTube may be available. We have given the faux pas at the beginning of the session, maybe it won't be available. And in the meetup, I'll post a link to the GitHub repo where where the sample is.
I actually have a project. It's kind of curious, like get some feedback on it. I'd like to see if it works for folks who are using Windows. The only prereq is to have Docker Compose, actually just Docker and Ruby. So if anybody can help me out, get with me afterwards. I'd appreciate it.
For sure. Not me, no Ruby, but maybe somebody else.
Yeah, actually, it just needs to have Ruby installed on your computer, any version of Ruby.
Oh yeah, okay. So if it's just configuring, I'll ping you.
Sweet.
Just drop how you want to be communicated with in the chat maybe, and I'll follow up with you. Or again, anybody else as well. It doesn't have to be me.
Appreciate it.
Okay.
Or somebody on the team. Yeah, cheers.
Can you hear me now?
Yes.
All right. It defaulted to the wrong microphone. That threw me off. So I want to thank you very much for these. I came to a I think maybe some of the .NET stuff. This was a little bit easier to follow than the .NET group for me.
Cheers.
Have you ever like thought about doing like scalability with containers? Because I think that would be an interesting presentation.
Scalability with containers?
Yeah.
Yeah, for sure. I think that's another great great topic. It's really cool to see it in action and some of the use cases. So for sure. Again, there's probably two forms, ECS and or Kubernetes. I mean, Kubernetes is built for, orchestration, which would include spinning up, spinning down.
Yeah. I just asked because it seems so important in today's day and age.
Yeah, for sure. I like the topic.
I would double down on a talk on Kubernetes would be awesome.
Cool. I figured it wasn't a good place to start, if you know what I mean. It takes this content and probably a few more things, and then we can get into it. It's not that bad actually, but there can be quite a bit to it.
Does anyone even use Docker Swarm? Like I know it's a thing. I very rarely hear anything about it though.
The only time I hear about it is legacy, people who started doing Docker, 3-ish years ago and earlier. Because for a while Kubernetes was like there was Swarm. Kubernetes was just starting to become a thing, and there was another one. I mean, Service Fabric, Microsoft Tech, and it didn't really support containers out of the box, but it does have that orchestration element. In the initial incantations, you built your code for Service Fabric. You were writing Service Fabric code. You grab Service Fabric NuGet packages or whatever, and you were writing native Service Fabric code. But once you did, you had all this pretty cool capability built into the platform. So it was almost more, not just containers. It was something else. And then there are a few others which, whatever. I can't remember. But so I'm sure people use it. I doubt that anybody who's paying attention would start a new project with Swarm, but I could be wrong there.
Gotcha. Thanks, Phil.
Yeah, cheers. Okay. Thanks all for coming. Appreciate it. We'll catch you on the next time. Leave comments, give feedback. We do have a survey out there, which maybe I'll republish. So any feedback, we appreciate. We're kind of flying blind here without feedback, doing what we think is best, and sometimes that's okay, sometimes not so much. So do let us know. Cheers. Thanks, everybody.